Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So we are talking about a planet that starts off its path by traveling at 20.9 kilometers per second. 9 kilometers per second, and ends its path at negative 18.5 kilometers per second, meaning during its orbit, this planet reverses direction, like most planets do, and its time it takes to get here is 2.16 years. Now, this problem is really kind of checking one big thing, first of all, and that's if you're comfortable translating all of these units into standard notation. Because the first problem asks us to find the change in velocity for these different, for this situation, but it asks us for us in meters per second, so I need to take my kilometers per second and convert it into meters per second. Now, the nice thing here is that kilometers is one unit we should be pretty familiar with because 1 kilometer is always equal to 1,000 meters. So when this is saying 18.5 kilometers per second, what it's really saying is it's traveling negative 18,500 meters per second. Similarly, for that initial velocity, we have 20.9 kilometers per second or 20,900 meters per second. Okay, so we are getting there. Now we have 2.16 years to convert over. Now to convert this, we're going to have to kind of break it up a little bit into some different pieces. 2.16 years. We want to multiply years by the number of days there are in a year. So 1 year is 365 days. Then the number of hours in a day. So 1 day is 24 hours. Then by the number of seconds in an hour, which is a useful number to keep in your head, is 3,600 seconds. And when we multiply all that across 2.16 times 365 times 24 times 3,600, we end up with the staggeringly large amount of 68,117,760 seconds. Okay, now at this point, we've done a lot of kind of background work to get ready to solve this problem. And now we're actually going to get into solving the problem. A is asking us just to find the change in velocity of the planet. And change of anything is always the final value minus the initial value. So in this case, that is negative 18,500. We want to be very careful with our signs here, minus 20,900 for a final change in velocity of negative 39,400 meters per second. And it is larger in magnitude than either of the other ones because in order for this planet to slow down and reverse direction, it first gets rid of all that initial velocity it had, and then it gains all the negative velocity. So that's why it's the summation of both of those. And then the last piece here, part B, is asking us to find the acceleration of the planet. And from our equation I have jotted down over here, acceleration is equal to your final velocity minus the initial velocity, and that whole thing divided by t. Now, we actually figured out what that v minus v naught is already. We have negative 39,400 meters per second. And then the time is that huge 68,117,760 seconds, which when we put that in to get our answer, we get a very, very small acceleration of negative 5.8 times 10 to the negative fourth meters per second squared. And that's our answer for part A. And that negative sign is because our velocity started out in a very large positive direction and then ended at a very large negative value. So it's a negative acceleration that entire time.